All right, so we have come to an end of this lecture stream. So now let me summarize everything. In this lecture, we saw this cross-validation technique to get a realistic estimate of a test error when we do not have a lot of data. So, and by the way, probably recently we hear a lot about deep learning and about these super complex models that we use like a lot of data to train, something like, I don't know, computer vision or natural language processing. Now, while this is true, so for these models, cross-validation is probably not really important because just that there is just too much data available for training. But in practice, we hear so much about this model because it's just hype, you know, it's everyone talks about it. But in real life, very often you have to deal with situations where a lot of data are not available, and data sets, practical data sets, are relatively small, and you will have to use more simple techniques like, I don't know, linear regression or polynomial regression or random forest or whatever very often. And for these cases, cross-validation becomes extremely useful, So cross-validation allows us to estimate a test error, and it also allows us to do model selection, right? So if we have a lot of models, something like a family of models parameterized by degree, by some hyperparameter generally, so like polynomial regression of an unknown degree, so or k nearest neighbors parameterized by k. So in future we'll see that, you know, the other models like regression, decision trees and support vector machines and, well, artificial neural networks, they also have these hyperparameters that can be fine-tuned using cross-validation. So a completely different technique is called Bootstrap. So we also saw this Bootstrap procedure in today's class, in today's lecture, and Bootstrap is something different. It is also a resampling method, but its purpose is completely different. Right? So it is, so we obtain, we use it to obtain some reasonable estimates. Usually we are interested in variance. So we have a unique sample, right? And we, for that unique sample, we derive some statistics from that sample. In the lecture, we saw this, the optimal estimate for variance, the optimal estimate for the fraction of our capital that we need to invest into different portfolios. But in practice, maybe you will be interested in some other statistics. But the main point is that so you can calculate this estimate for your statistics from your sample, from your data set, but you will not be able to obtain the estimate for the variance. So you will not be able to quantify uncertainty. And Bootstrap is a very powerful method to quantify uncertainty. So when you know, in a real set scenario, when we do not really know our true population. So these are the main takeaways, and here is the list of concepts that we learned in this lecture: validation set, leave one out, cross-validation, k-fold cross-validation. So these are three techniques for cross-validation. In practice, we actually use just the k-fold cross-validation. And Bootstrap is used for a different purpose. Okay, so that was the end of the lecture. Thank you very much for your attention.